So, what is radioactivity? Radioactivity is when particles are emitted from a nuclei due to instability in a nucleus, and basically the particles are emitted over and over until the nucleus is finally stable again. So the three most common forms of that are alpha, beta, and gamma. So today we're going to be talking about those three and ultimately how this all relates into physics.
To start off, radioactive decay is measured in terms of half-lives. Initially, a concept in marketing and finance. A half-life is the amount of time it takes for half of a substance to go through some specific process, such as an element losing a certain amount of atoms. The duration of a half-life varies across each element.
So for example, uranium-238, while it's relatively weak radioactively, it has an extremely long half-life, so it's lasting for like 4.4 billion years, so that means like even when the sun is gone, uranium is still going to be here. It's kind of cool.
Wow.
Yeah.
It's cool.
Pretty sweet.
Alpha radiation. Basically, in alpha radiation, an alpha particle composed of 2 protons and 2 neutrons is the same as the nucleus of helium. During the process of alpha decay, the alpha particle escapes from the nucleus and positively charges both itself and the nucleus. This causes the original atom from which the alpha particle came from to lower in mass by 4 and in atomic number by 2, ultimately meaning that it's now a different element. For example, if uranium-238 went through alpha radiation, it would now be thorium-234. So basically, in alpha radiation, the atom will become radioactive when a proton and a neutron, 2 of each, get out of the atom most of the time, and that causes this atom to go through alpha radiation.
So beta radiation is, it can occur in 2 different forms. So there's positive and negative. So beta negative occurs when a nucleus neutrons transforms into a proton and electron and an anti-neutrino. So productions of nuclear fission reactors often go through beta negative due to the excess amount of neutrons. And then beta positive has a similar process, but instead involves a proton changed into a neutron, a positron, and a neutrino. So just basically flip everything around and there you go.
Yo, that's wild. Basically how beta radiation works is the regular atom will have one of its neutrons turn into a proton. And when the change occurs, its electron starts to circle around it, and that causes it to become radioactive. Gamma radiation. Basically how this dude was made is fiction. This is a lie. Hulk is not real, and gamma radiation did not affect him because he's made out of actual fiction. But basically how gamma radiation does work is, after an alpha or beta radiation, an atom can still sometimes be left in an excited state with an excess amount of energy. In order to get rid of this energy, the atom emits a gamma ray. This is similar to how an electron emits a photon in order to lower energy. Out of the 3, gamma radiation is the most powerful and can even pass through several centimeters of lead. In comparison, beta particles will be absorbed by a few millimeters of aluminum, while alpha particles, being least powerful, are easily stopped by air and even paper. Basically how gamma radiation works is, there's an electromagnetic wave that hits the atom, normally caused by a different nucleus that has gone through a different type of decay, and it's normally high on energy, so So basically, one of the many things that radioactivity is used for is in carbon dating. And in carbon dating, basically, the atmosphere is filled with about 78% nitrogen. The reaction of carbon dating happens rarely, but once in a while it occurs. There are cosmic rays or particles in space that will occasionally hit the atmosphere, and these cosmic particles are filled with neutrons. When they hit our atmosphere, rarely when one of these cosmic neutrons hits the nitrogen in our atmosphere, it will hit perfectly where a proton is, and this causes a reaction where the proton switches with the neutron. This causes the nitrogen with 7 protons to become carbon with 6 protons. That atomic mass stays the same because the neutron and proton has the same atomic mass, but the atomic number changes. A good example of half-lives being used is with carbon dating. When archaeologists find bone, they measure how much carbon is left in the bone compared to living things. A good example of half-lives being used is with carbon dating. When archaeologists find dinosaur bones, they measure how much carbon is left in the bone compared to a living thing. They also know that the half-life of carbon is 5,730 years. So, if they find a bone that has half the carbon of a standard living bone, then they know it would be about 5,730 years old.
So radiation affects the human body by killing cells. So the severity of the radiation depends on how long you've been exposed to that environment. This is measured in sieverts, a unit of measure when referring to radiation in biological tissue. So for example, when getting a dental x-ray, you're exposed to 1 millisievert worth of radiation, and a full body scan exposes you to 10 millisieverts.
If you're exposed to 1 full sievert, the mass amount radiation will most likely give you radiation poisoning and damage vital organs. Up to 2 or 3 sieverts is much more threatening and can cause these same side effects, but also threaten your immune system due to the large amount of white blood cells being lost. Out of the different form of radiations we've talked about today, atoms that undergo alpha radiation are the most dangerous because of how easily they can be absorbed when airborne.
Alright, so that's our project. We hope you enjoyed. Hope you learned a few things about radiation and how it all works with physics.
Yeah, and clearly, as you can tell from our project, is radiation isn't the best thing. It is extremely unnatural, and it has poor effects on the human body. So if you don't want to worry about, I guess, the world's health, worry about your own. So don't try to go blowing up nuclear reactors, or let's not pour nukes on other countries, because in the end it will probably kill us all.
Yeah, bro. Well said.
Yeah, well said.
All right.